Hello everyone. Today I will discuss GATE previous year question paper year 2003. The subject is refrigeration and air conditioning. So let's move to the first question. So this question talk about an industrial heat pump operates between the temperature 27 degree centigrade and minus 13 degree centigrade. So the rate of heat addition and heat rejection from the heat pumps are given. So these are 750 and 1000 watt. We have to find the COP. So first of all, you have to understand what is a heat pump. It's a very simple question. So let's understand what is a heat pump. So heat pump is a device which transforms the heat from colder area to a hotter area by using mechanical energy. So as you know from thermodynamics, if you have to transmit the energy from sink, that is a body at a lower temperature, to a body at a higher temperature, that is source, you have to done some work. So in heat pump there is a sink at a temperature T2 and a source at a temperature T1. So driver is giving some work input to the heat pump. So the COP of the heat pump can be given as desired effect by the work input. So in case of heat pump, the desired effect is obtained in source, but in case of refrigerator, the desired effect is obtained in sink. So if you think a pump, for example a room heater, you have to heat the environment, so you have to heat the sink, so your desired effect will be obtained in source. But if you take an example of refrigerator, you have to maintain the temperature of the lower body. That means the lower body is what? The evaporator, the inside of the refrigerator. So in case of refrigerator, the desired effect is obtained in sink. So therefore the COP of the heat pump is given as Q1 divided by Q1 minus Q2, where Q1 is heat rejected from the HP, that is heat pump, to the source, and Q2 is heat taken or addition from sink to the heat pump. So now in the question we have Q2 is equal to 750 watt and Q1 is equal to 1000 watt. So you can put this value. So here COP you can calculate it using this formula and you will get 4.0. So the answer will be C, 4.0. Now next we have to move to the next question. So the problem 2, it says for air with relative humidity 80%, what are the following options are correct? So to understand this problem, we have to know what are the properties of air. So and you have to know some basics like dry bulb temperature, wet bulb temperature, dew point temperature, relative humidity. Okay, let's move to our psychometric chart. So this is your psychometric chart. So I take a point in the line of humidity of 80%. So if you draw a vertical line which intersect at the x-axis, you will get the dry bulb temperature, and you can see the wet bulb temperatures lines. So if you draw the line, join the line, you can see here sky blue color, then you will get your wet bulb temperature. Now if you draw a horizontal line through this point which intersect at wet bulb temperature, when the humidity ratio, or sorry, the relative humidity is 100%, then you will have the dew point temperature. Now you can clearly see that the dew point temperature is less than the wet bulb temperature. So the correct option will be your B. The dew point temperature is less than the wet bulb temperature. So next, our problem 3. So some data are given. So the problem is of Fischer cycle. So a refrigeration based on ideal Fischer cycle operates between the two temperature. One is minus 20 degree centigrade, another is 40 degree centigrade. The refrigerant enters the condenser as saturated vapor and leaves as saturated liquid. So this is a very important line for the problem. So you have to remember this. So the enthalpy and entropy values are given at different temperature. So we have to find the refrigerating effect and COP, given that the circulation rate is 0.025 kg per second. So let's move to the solution. So this is your temperature entropy curve. So here from point 1 to 2, this is your compression process in compressor. So the 2 points intersect at the saturation vapor line, since the question itself saying that the refrigerant enters the condenser as saturated vapor. Also, it leaves as saturated liquid. So from point 2 to 3, it intersect at point 3. That means point 3 lie on the saturated liquid line. So this is your TS diagram for this question. Now these are the data given: H2, S2, H3 and H4. Now to determine your desired effect, that is for the process 4 to 1, you have to know what is H1. So to determine COP as well as desired effect, you have to determine the value of H1. So for that, from the TS diagram, you can see S1 is equal to S2, because from 1 to 2 it is a isentropic compression process. Okay, this is an ideal Fischer cycle. So S1 can be calculated using the dryness fraction, that is SF plus X into S of Fg. So these values are given. Sfg is Sg minus Sf. So putting all this value, you will have the value of dryness fraction is equal to 0.90. So now you can calculate H1. So the H1 value will be 20 plus 0.90, 180 minus 20. So your H1 value will be 164 kilojoule per kg. Now you can calculate your required values. So refrigerating effect QR for process 4 to 1 will be H1 minus H4. If you need this in kilowatt or watt, you have to multiply this with your mass flow rate. So we will have a value 2.1 kilowatt, and for COP, H1 minus H4 divided by H2 minus H1. H1 minus H4 is your desired effect for process 4 to 1, and H2 minus H1 is your work input. And in case of Fischer cycle, our work input is compressions process. So if you put all the value, you will get the COP of 2.33. So for today, I discussed 3 problems which come in GATE 2003 in the for the subject refrigeration and air conditioning. After that, I will cover 2004 for the same subject. So thank you for today, and subscribe to my channel if like it. If you have any doubt, please comment down. Thank you.